Welcome back to Mastering Vuex. In this lesson, we'll look at committing mutations to our state, we'll look at how we can wrap our mutations within actions, and then we'll use both mutations and actions to add events to our example application. Let's get started. Mutations can update or mutate the Vuex state. Now, if our store had the state of count, for example, we could write a mutation and call it increment count. It can take in this state and use that state to increment the count by 1. Now, let's look at committing this mutation from within a component. In the script section, we could have a method and call it increment count, and it could say this.$store.commit and then the name of the mutation we're committing, in this case, increment count. Within our template, we could have a button that's listening for clicks, and when it hears clicks, it'll trigger the increment count method. So if we click this button, the method will fire, the increment count mutation will be committed, which will update the state of our count by 1. Now you might be wondering why these mutations are written in all caps. This is common in flux-based patterns, which Vuex is designed after, but it's entirely optional. You'll also see mutations written in camel case, so it's up to you. However, the advantage to having it all in caps is you know exactly what mutations are available to you when you look at your files, and it will be very clear when you're committing a mutation versus calling an action. Now, let's take a look at dynamic mutations. In our same counter example, we could add an input element here and use vModel to bind it to this increment by data value. We can pass in increment by as a payload where we're committing this mutation, and our mutation can receive that payload. So now instead of incrementing by 1, we'll increment the count by the value that we just received. Note that we're using the .number modifier. That'll make sure to typecast whatever is input as a number. And since this is bound to the increment by data, if a user were to type in 10, the data would be 10. Then when they click the button, it'll trigger the increment count method, which will commit the increment count mutation with a payload of 10. The mutation will receive that payload as a value and update the state of count by 10. If we take a look at the Vuex DevTools, we can see that our mutations are being logged here, and that as we click on them, we can see the state at the time that they were committed. This allows us to do what is called time travel debugging, so that we can see what the state of our application was at the times that are logged here. Now, let's take a look at actions. While mutations are synchronous, meaning they happen one right after the other, actions are asynchronous, meaning the order in which the code is written within an action might not actually be the order in which that code is executed. And sometimes this is the behavior that we want. In a previous lesson, we looked at how Axios is asynchronous, which is exactly the kind of behavior that we would want. Actions can wrap business logic around mutations. As we saw in our Intro to Vuex lesson, we looked at how an action set the isLoading status to true, then made an API call, and when that response returned, it committed another mutation to set the isLoading status to false, and then a final mutation to set the to-dos state with the response we got from the API. Let's look at a real-life metaphor for mutations and actions. If I were to text my friend and ask them, hey, can you pick up some bread? The picking up the bread itself is more like the mutation, whereas me asking for her to pick up the bread is more like an action. So if possible, go to the store and then pick up bread. But actions don't always commit their mutations based on how the logic within that action actually unfolded. In our real-life example, my friend's car could break down, or the store could be out of bread. According to members of the core Vue team, you'll always want to put mutations within actions, even if you have an action that is dedicated to just one mutation. The reason for this is because this future-proofs your app. While you might not need business logic around that mutation now, as your app grows, you might need it later, and that could require quite the large and unnecessary refactor that you wouldn't have to do if it was already wrapped within an action. So doing so increases your scalability.
Now let's see actions in action.
In our same counter example, in the store.js file, we'll add an action called updateCount, and it's taking in this context object. The context object is an object that contains all the properties on the Vuex store, such as state, commit, and getters. Right here, we're using object destructuring to just take out the state and commit. We're also receiving a payload here, then committing the increment count mutation and sending in the payload to it. Now, instead of committing increment count in our component, we will dispatch update count. And this is where we will initially pass in the payload.
Now that we understand how mutations and actions work, let's implement them within our example application.
We're going to be adding the feature for a user to create their own events, which are added to our application with mutations and actions. The to-do list for this section includes first installing a new dependency that we'll need. Then we'll flesh out our event create component, then add a mutation and action to our Vuex store that will allow us to add events to it. And then once the event is created, we will route to that newly created event. So let's get started. First, we're going to install a dependency called Vue.js DatePicker. Like it sounds, this is a DatePicker component. We'll say npm install Vue.js-DatePicker --save. And this will save the library into our project. Now I'll go ahead and delete lines 4 and 5 because we no longer need them. And in the script, I'm going to import DatePicker from our library, Vue.js.DatePicker. Now I'll register it as a component of event create. Next up, I'm going to add a form to our template. I'll just paste it right here. And this is code that you can find below this video. Go ahead and indent it. And as you see, we are asking a series of questions and then taking in the response through inputs, which are v-modeled to our event data. On line 31, you can see we're using our DatePicker component. Now we just need to add a simple scoped style. Now we can take a look at this component in the browser. As you can see, it's asking these questions. We're taking in the responses and inputs, but with this select time and select category, we haven't yet filled these select inputs with data for their options. So let's do that now. We'll add our data, and we're going to be adding an algorithm for our times data. We'll create a const times array, then use a for loop. We'll start it at 1 and have it go through up to 24. And then we'll be pushing I plus :00 into our times array. This will give us an array of times values to use in this component. And since times :times is the same as just times, we'll delete that. Now we want to retrieve our categories from our Vuex state. If you remember from our state, we have an array of category strings here. So we'll say this.$store.state.categories, and that'll pull them in to this data property. Now if we scroll up, we can start using this data. Here in this select input, on the option element, we're v-foring through our times to print out each time. And if we scroll above to this select input, we are v-foring through all of our categories and printing them out. Now, back in the browser, if we open this up, we can see all of our categories, and then down below, all of our times. Now, let's start creating our event data. Again, all of these inputs from our form are bound to this event object. We're going to do something a little different here. We'll say this.createFreshEvent object, and as you can see, it's a method. So let's add that method below. So what this does is it creates a const for our user, using whatever user is stored within our state. Then we're creating a random ID for each event. We'll say math.floor, then math.random times 10 million. Then below here, we're going to return an event object. For the ID, we'll use the ID const we just created. Then for the user, it'll be the user const. Then I'll paste in the rest of the properties. Now here, when our event calls this method, it will return this object for our event data.
If you're wondering why we didn't just add this event object directly to our data, that's because we'll use this method later to clear out our event data. This will make sure that we don't retain any unnecessary connections between our local component's event data and the event that we send up to the Vuex store.
Now let's start adding our mutation and action to the Vuex store. First, we'll write our mutation. We'll call it addEvent. That'll take in the state and an event as the payload. Then it'll say state.events, which is this state right here. And we're going to push the event that we just got in as the payload into this array. Now, we need to import our event service because we're going to be using it in the action we're about to create. We'll import event service from where it lives in the services directory. Now we can start writing our action. We'll call it create event. It'll take in commit from the context object, and then event as the payload. And then it'll commit the addEvent mutation and pass along the event payload. But we don't just want to put the event into our state, we also want to post it out to our mock database. So we'll use event service.postEvent and send in the event here. If we take a look at the event service file, we can see there's a new post-event method. It takes in the event and then posts it out to this endpoint, which will add it to our mock database in our db.json file.
Next up, we need to dispatch the action from within our event create component.
So we'll write a new method called createEvent, which will say this.$store.dispatch, and then the name of our action, createEvent, and then the payload, this.event. Now, when we want this to happen is when our form is submitted, so we'll say @submit, and then .prevent to prevent the default behavior, and then createEvent, which is the name of that local method below. Now, when the form is submitted, we'll trigger this event, which will dispatch our action. We'll test this out real quick. Is it working? Submit. Back over on our event list. Yep, we can see it did work. Awesome. Now, let's just double check that our event was posted to our local db.json file. Take a look in db.json. There it is, with the title of working.
Now we want to reset our event data object.
We can say this.event, referring to our event data, and then call the createFreshEvent object from here. This will clear out whatever our user had input. But there's a problem with this. We only want to reset when the event has been successfully added to our database. For example, a user could be adding an event, then walk into an elevator, hit submit, we clear that event, but it never got submitted to the backend. We don't want that to happen, so we can prevent that. We'll head over to our store, and here we will return event.service. We'll add a .then. So now when the API call responds, then we'll commit the addEvent mutation. And we can also wait for the response to return within our dispatcher. So what do I mean by dispatcher? I mean right here, where we're dispatching the event. So we'll say .then here as well, and then only clear the event when the API call response from our action is returned. And if it doesn't, we'll catch it, and then console log, there was a problem creating your event, to the console.
Once a user creates an event, we want to route them to the event they just created. Let's implement that now.
We can say this.router.push, which is a view router method that takes in the name of the route we're pushing to, in this case event-show. And then also, if you remember from our view router lesson, this route takes in a param of ID, which will feed in this.event.id. Now, just make sure that we're clearing out this.event after we're setting the ID. Otherwise, this.event will be undefined. Now, looking in the browser, let's test this out. We'll create a nature event and plant some trees in the forest. And when we submit, we're taken to the event show route, which is displaying the event we just created. But there's a minor detail we need to correct for here. We're displaying the entire user object, but we can fix that quickly. We'll go into the event show component, and if we have an event.organizer, we'll print out event.organizer.name, otherwise an empty string. This is the same thing that we did with the attendees below in an earlier lesson. Now we're displaying the organizer's name correctly.
Let's review. In this lesson, we looked at how mutations can update our state. Then we looked at how an action can contain a mutation or mutations that it may or may not commit. Then we used a mutation and an action to add events to our state. We'll see you in part 2 of Mutations and Actions, where we look at fetching data. See you there.